So hello everyone, this is lecture 12 for the nuclear physics. In the last lecture we have discussed all the questions based on the radioactivity, and today we are gonna start, that is nuclear reactions. So we'll study in this about the Q value. So this is the very important topic for the exam point of view. So what is Q value? If you have any reaction like A plus B in converting into C plus D, then first you need to see that there will be conservation of energy definitely. So for A and B, it will be total energy will be simply rest mass energy plus the kinetic energy of A, then rest mass energy of B and kinetic energy of B. So that will be MAC square plus Ka plus MBC square plus Kb. And now this will be equal to, this must be equal to the total energy of C plus D, that is MCC square plus Kc, MDC square plus Kd. Now we just separate the terms with the C square and the kinetic energy. So that will give us Ma plus Mb minus Mc plus Md C square and Kc plus Kd minus Ka plus Kb. So you can see this is called the Q value, and this also can be seen as the change in the energy, or the energy released, or the energy absorbed, because this mass is changing into this. So it will be depending on that how the mass is changing, it is decreasing or increasing, and kinetic energy will be based on that only. So there will be three cases developed after this. This is called the Q value actually. So you just need to take the mass difference multiply C square, that will give you Q value, or either you can take that difference between the kinetic energy of product minus the reactant, or mass of reactant minus mass of product. So you must remember this formula as it is, only then you can solve the questions. So there will be three cases. First, if it is exothermic nuclear reaction. What is the meaning of exothermic? Means energy will be released. So energy will be released means Q must be positive. So Q will be positive only when this term will be greater than this, means mass of reactants is greater than mass of product, means some mass is lost after converting into C plus D. So that mass is lost in form of energy, means this kinetic energy will increase of products. That's why this will be greater than this Kc plus Kd. So you can see that energy will be released. In this reaction some mass is lost, that mass will be converted into energy and it will be released in the form of kinetic energy. This kinetic is carried by the products. So Q is positive because Kc plus Kd will be greater than Ka plus Kb. So that's how you can relate that how they are. Okay. So the final energy will be means initially there was this kinetic energy of these masses and plus some mass that will convert after the reaction into the energy. So that is K initial plus delta E must be equal to total energy after the conversion, that is Kc plus Kd. So this is K final also. So K final minus K initial is simply this delta E. So this mass change here to here will convert into the energy. This is what this is showing. Okay. Now there was second case, that is endothermic nuclear reactions. Here Q must be negative or less than 0. So Q will be negative only when this will be less than this, means this mass is less than this, means some mass is created after going from A plus D to C plus D, and that mass is created because of some energy is consumed here, means some energy is added to the reactants, that energy will convert into the mass, and that's how it will become. So here the kinetic energy of this means, now you can see that this must be less than this. So kinetic energy will be reduced, means that energy which is given to it will convert into the mass. So mass is created. To create the mass required in this reaction, we have to provide energy from the outside. This energy can be supplied to the reaction in the form of the kinetic energy of the reactant. So in the endothermic reaction, energy will be absorbed. So Q will be negative only when this K final plus delta M C square, this mass is created. So this will be the final kinetic energy plus this mass created, that energy equal to the initial kinetic energy. So from here you can see Kf minus Ki is simply minus del M C square. So that's how you can see Q must be negative. There is third case when there is this is called the elastic collision, and you can see elastic means there is no change in the energy or the masses. So if no change in energy is there, then definitely there will be no mass change also. So that is the case of elastic collision, means mass will remain same and the kinetic energy will remain same, only the direction can change after the, means if there is one nuclei, two nuclei, they are reacting, and after that they can go like this, so anywhere, so that direction may change, but there will be no loss of energy or mass, but direction of motion particle is changed. So you must remember these three cases. Now let's discuss the Q value for different kind of reactions. First, for the alpha particle decay. So alpha emission reactions, what is the Q value for them? So there will be question asked from these, so that's why we are discussing them. So this is your nuclei AXZ, this is emitting alpha particle, so this A minus 4 will be there, and Z minus 2 because of the helium atom has 2 Z, and 4 is the total atomic mass, so it will be A minus 4 Z minus 2 plus helium atom. Now how you can find the Q value? Simply the mass difference, mass of this X nuclei minus the mass of Y and this helium. So this will be mass of nuclei minus my nuclei and helium nuclei c square. So in general, they won't give you the mass of nuclei, they can give you the mass of atom. So how you can find then? So mass of atom minus the mass of total electron inside this x nuclei, that will give you mass of x nuclei. So mx atom minus z, it's total. Okay, z is the number of the electron also. So z me will give you the mass of nuclei. Similarly, my nuclei minus z minus 2 electron, mass of electron, minus this m of helium atom minus 2 electrons are there. So that's why. So that is also giving you the same thing. Okay. So we are neglecting here the binding energy of electron because it will be in the order of 10 electron volt, and this reactions are occurring at the mega electron, means this mega electron volt. Okay, that's why we are just neglecting binding energy of electrons. So if you solve this, then it will be minus ZME, and minus plus will give you plus ZME, and minus ZME will cancel out. So it will simply turn out to be mx atom minus my atom minus m helium atom multiplied by c square. So in general, it won't occur like this, but for the alpha particle, you must remember this, that it will be like this. Okay, if these masses are given in AMU, and then this you just simply can multiply with 931.5 mega electron volt, and this q will came out to be in mega electron volt. Okay, so that's how you can just remember this. So this will be a very easy form, means if it is mass in AMU, then just multiply with 931.5, it will give you energy in mega electron volt. Now there is second case, means if they ask you to find the kinetic energy of this alpha particle, or the kinetic energy of alpha particle is given and they ask you to find the q value. So there will be a very simple method we can derive, that is, we just assuming that x nuclei is initially at rest. Then when it break out after the reaction, it will like go for y is like this and alpha is like this. So they will have the same momentum. Means from the conservation of momentum, you will see that initially it was 0. So after final momentum must be 0. Sum of py plus p alpha must be equal to 0. So py equal to minus p alpha. So now see what is the q value we know. That is the kinetic energy of product minus the kinetic energy of reactant. So kinetic energy of product is ky plus k alpha minus the kinetic energy of reactant is 0. So it will be minus 0. So it will be simply ky plus k alpha. So this will be your q value. So we need to find this ky k alpha first. So conservation of momentum will give you this, and mode of momentum will remain same. That is, we can say py equal to p alpha, the mode, and kinetic energy is simply p square by 2m. So py square by 2my. So py can be written as p alpha, p alpha square by 2my, and k alpha will be p alpha square divided by 2m alpha. So it will be p alpha square by 2m alpha. Now kinetic energy ratio will be ky by k alpha will give you m alpha divided by my. So this will be a ky by k alpha. Now just you can substitute here ky equal to m alpha by my k alpha. Substitute here and you will get this. So m alpha is simply 4 divided by my is nothing but a minus 4. So a minus 4, and here it will go 4 plus a minus 4 will give you a in the numerator. It will be a minus 4 k alpha. So this will be a q value. Approximate value of k means q value for the alpha emission decay. So you must remember this. This is a very important equation. They can give you k alpha, they can ask you q, or they can give you q, they can ask you k alpha. So you must remember this formula. Now next is q value for the beta emission decay. So beta positive emission, that is the one proton is converting into the neutron and the positron. So that's how, if this proton is decreasing, that's why z minus 1, and neutron will add it, that's why a will remain same, and one positron is emitting, and this is your neutrino particle. This mass is neglecting, this is a approximate 0 mass. So q value for this beta emission decay is simply mx nuclei minus my and minus me. This is the mass is same for the positron and the electron. That's why. So again, if they give you the mass in the atom, mass of the atom, then just minus the electron's mass, and you will get this equation. And again minus zme minus zme plus zme, this will cancel out, and in the last you will get this. So what is the thing we need to extract from here? Very important thing, that if there is beta positive decay, then this must be positive, and because energy is always released in the beta positive decay with in the form of this kinetic energy of these. So if the kinetic energy must be released, then this must be positive. So this must be positive only when this mx minus my is greater than 2me. So you must remember this, only the beta positive decay can occur when this mass difference is greater than 2me. So you must remember this. Okay, for beta positive emission. Next is q value for the beta negative emission. Now here this one neutron is decaying into the one proton plus one electron. So that's why it will z will increase to 1, and there will be this electron will be emitted. This is beta negative decay, and this is your anti-neutrino. So again we will apply the same formula, mass of this nuclei minus the minus of y and minus of beta, or the minus of electron. And again if it is given in the terms of atom, then it will be like this, and it will solve to give q beta as this. So you must remember these formulas for different kind of decay. So they will ask you directly, and you can solve them. Now there is one more thing today. That is Q value for 2D nuclear reactions. Means if there is 2D nuclear reaction, like there is this nuclei, this is your M1 particle, it is going to react with this, and after the reaction it will go like this. Means there will be some M3 particle and M2 particle. So the kinetic energy of this K1, and this is K2, this is K3, this is K0, and this is initially at rest, so this is why K2 is 0. So how this will occur? They can ask you that what is the kinetic energy of K2, because this is a small particle, this is a decay, so that's why K3 will be known and K1 will be known. So they can ask you K2, or one of the angle theta or phi is given, they can ask you another angle, or they can ask you directly the angle also. So means there will be some unknown terms and some known terms, so they can ask you in the same way, and they can ask you find the Q value of this reaction. Okay, so how you can solve this in the 2D, means this is your x and this is your y. So we'll use the particular formulas. Means like Q value is simply kinetic energy of K3 plus K2 minus the kinetic energy of reactants. That is this, for this is 0 for this. So K2 plus K3 minus K1 will give your Q value. And now to find the angles, what we do? We just take the conservation of momentum, linear momentum. That is in the x direction it will remain same. So if this mass is m1 and kinetic energy is k1, so momentum is simply under root 2m k1 2m1 k1. So this must be equal to the x component of this and x component of this. This will be under root 2m3 k3 cos theta and under root 2m2 k2 cos phi. That must be equal to 2m1 k1. So we get this first equation. From here, if we need to find the theta, then we will write this equal to this minus this. If we need to find the phi, then we will write this equal to this minus this. So that's how you can just convert accordingly. Now for the linear momentum in the y direction, initially in the y direction momentum is 0. So this must cancel out, means the y component of this one must cancel out this one. So they must be equal. So this sine theta must be equal to sine phi of this. So we get the second equation or the third equation. Okay, now you have this. So now you just divide this equation 3 by 2. So you will get tan phi equal to this. If you need to find the theta, then you will get this equation in theta terms and you can just divide them accordingly. Okay, so you can find phi or theta from here. Now if you have already the phi and theta and they ask you find the K2, so how you can find the K2? So for that you just square the 2 and 3 and add them. This will give you sin square phi cos square phi, and it will be 2m2 K2. This will give you sin square plus cos square phi as 1. So you can just square 2 and 3 and add them. So you will get something like this. Okay, then you just divide it by the 2m2 and you will get K2. This will be your K2. And now they ask you the Q value. So Q value is simply K2 plus K3 minus K1. So write the value of K2 from here, and you already know what is K3 and K1 because this will be given and it can be measured. So you can find the Q value and this will be your answer. Okay, so that's all for today. In the next lecture we'll discuss all the questions based on the nuclear reactions and then we will move forward. Okay, so thank you everyone.